For question 5, it says, consider the curve defined by this equation, x squared plus 3y plus 2y squared equals 48. Now, they said it can be showed that the derivative, dy over dx, equals negative 2x over 3 plus 4y. So we didn't have to find that. They just gave it to us. Now, for part A, it says, there is a point on a curve near to 4 with x-coordinate 3. Now, this took me several reading throughs before I understood. And basically, the idea is that this point right here is on the curve. That's the key point right here. And so now you get that by this context right here, by they reiterating that point to say, use the line tangent to the curve at 2, 4 to approximate the y-coordinate of this point. So what we need is we need a line tangent. So we need two things to get a tangent line, a point. Now they gave us that. Now we also need slope. Now for slope, we need to get that from this formula right here. So we're going to plug in 2 in for x, and we're going to plug in 4 in for y. So we have negative 4 on the top, and we have 19 on the bottom. So our tangent line then is going to be y minus 4 equals negative 4 over 19, and then x minus 2. Now from that, we want to approximate the y-coordinate of this point with the x-coordinate of 3. So that means we're going to plug in 3 in for x. So that means what's in parentheses just reduces to 1. So we have negative 4 over 19. So I'm going to have to add 4 to negative 4 over 19. So down below here, we need a common denominator. So that is going to be 76 over 19. So when we subtract that, we get 72 over 19, and that is our y value for part A. Part B, it says, is the horizontal line y equals 1 tangent to the curve? We want to give a reason. So, horizontal line. So that means we have dy dx equals 0. So with that in mind, we're going to plug in 1 in for y, plus 4. So that means we have negative 2x over 7. So now 0 equals negative 2x, so that means 0 equals our x value. So given these conditions, we know that we have to have a y value of 1 and an x value of 0. The question is this horizontal line tangent to the curve? So what we have to do is figure out, is this point 0, 1 on this curve? So if I plug in 0 in for x and 1 in for y, does this work? Well, the answer is no. This produces a false statement. Okay. So that means the point where a horizontal line would touch the curve does not fall on the curve. Okay. So that is our reason, because the point 0, 1 produces a false statement. When applied to the curve. And there's probably several other ways you can do that. I've just given you 2 different ways to explain that as a reason. So letter C, the curve intersects the positive x-axis at the point square root of 48, 0. Is the line tangent to the curve at this point vertical? So this is asking, is dy over dx undefined? That is the question. So that means we plug in square root of 48 in for x and then 3 plus 0. So we get negative 2 square root of 48 over 3. And so, no, it is not. So let's clarify what it is. No, the tangent line is not vertical. Because the slope at that point is not undefined. Now, College Board may be picky about the use of the word slope, and they may want to say the derivative at that point, or they may want you to say dy dx at that point is not undefined. So we'll see what happens. Let's see how they rule when the grading guidelines come out. And then letter D. For at a time t equals 0, a particle is moving along another curve defined by this equation. At the instant the particle is at the point 2, 4, the y-coordinates position is decreasing at a rate of 2 units per second. At that instant, what is the rate of change of the x-coordinate of the particle's position with respect to time? Now, as I read this, pretty much the rest of this information is not important for what we're doing. It's all about this one. Now, what's important is decreasing at a rate of 2 units per second. And I tell my students, anytime you see per second or per minute or per hour, when a time shows up and t is not in the equation, your ear should perk up. Because this means that we are finding this with respect to time. So when I take the derivative, 3y squared times dy dt. And then for the second term right here, this is product rule. So this is 2x times dx dt plus 2y. Whoops, did that wrong. I left x alone. I find the derivative of y. And we're left with 0. So we have our x value of 4, so that's going to go here. We have our y value of 2, so that's going to go here and here. And then it says it is decreasing at a rate of 2 units per second, so that's going to go here and here, but that's going to be a negative. That's an important thing to keep in mind. When it's negative, that's because it's decreasing. So times negative 2 is 4. Okay. So this right here, this term is negative 24. This term is negative 16. So 4 dx dt equals 40. So dx dt equals 10. Now, important thing to note is that here, the y-coordinate of the particle's position is decreasing rate of 2 units per second. That's a unit. So we have to include that same unit per second on our answer here as well. All right, thanks for watching. We'll see you in the next one.